Hey, this is Math 6, Unit 2, Lesson 4, looking at color mixtures today. So we looked at the last time, we talked about how things, if you had them in the right ratio, then they would taste the same. We were mixing like some lemonade or some Kool-Aid kind of drinks and looking at recipes as well. And so now we're looking at some color ratios today, and that's what we're going to be talking about here. So here we go. First of all, we began with this one, which says find each product mentally. And so you got an activity, wants you to find each product mentally. And so perhaps when you looked at 6 times 15, when I look at this one kind of as a mental exercise here, I might think kind of 6 times 10 and 6 times 5, which is a 60 plus a 30 to give me something like about 90 there. Okay, might do it mentally. Just writing it down what I'm doing as well, just so you have an idea of what that looks like. Sorry about that. Took a second to get my projector back on. All right. When I look down a level, I got 12 times 15. So if that's 90, I can see that I'm going to be doubling it up from 6 to 12. So I'm probably at about 180. When I look here, what I see is that, okay, the 6 stays the same, but 15 is times 3 times more. So if I take my 90 and multiply it by 3, I'm about 270, something like that. And then when I look over here, I go, okay, well, this one's a little different, right? Because now I'm more than doubling it, and I'm more than tripling it there. So it's a little similar to the 180, except that I'm going to multiply it by 3, and then add another set to it, right? Something along those lines there. So this one's not quite as easy to mentally do, right? But perhaps I double it up, or maybe I look at this one, I go like double it up to get from 270 to make it 12 times 45. And 12 times 45 is going to be, in this case here, 540. And then I add another 45 mentally in my head, 585 to get there. Something along those lines might be what you would do. Again, just an idea to kind of get you close. Okay, let's take a look at today's activity. It says your teacher mixed milliliters of blue water and millimeters of yellow water in a ratio of 5 to 15. That's our blue to yellow. Okay? Doubling the original recipe. Draw a diagram to represent the amount of each color you will combine to double your teacher's recipe. So, if we began with blue being at 5 and yellow being at 15, that's a whole lot of Y's to draw. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. If we double that up, then we'd add 5 more blues, and we'd add another 15 Y's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Alright, that's what the diagram would look like there. Now it's getting kind of complicated to draw here because we're just going to keep drawing a bunch of Y's, and I don't want to triple it. That's a lot of B's, a lot of W's there, a lot of Y's there. So, in terms of what that would look like, okay, if we have a ratio that's 5 to 15, and we're doubling it, now we've gone from 5 and 15 to 10 and 30. That's what's happened to our ratio. Again, they're equivalent because we did the same thing times 2 here and times 2 there. And it says use a marker to label an empty cup with the ratio of blue water to yellow water in this double batch. So if we had a marker and we had to get a ratio there, we would label and say if I doubled it up, I'd be looking at 10 to 30 for the ratio of blue to yellow. That's the idea. So we've done this already before, but now instead of looking at how something tastes, we want to look at what does it actually look like. And the question says, predict whether these amounts of blue and yellow will make the same shade of green as your teacher's mixture, and next check your prediction by measuring those amounts and mixing them in the cup. So to do that here today, what I have, I'm going to use the kind of the QR reader on the applet here, and we can scan that in there, and we have our little activity online, which allows us to, if it all loads up here, allows us to make these mixtures here. Okay, so we're going to take our GeoGebra here, and we're going to see what this looks like, looking at the shade that we can possibly produce. Okay, so initially we said we were going to have 5 blue and then 15 yellow. So I can do that by doing 3 yellows because 3 times 5 is 15. So I'll go 1, 2, 3. So that's a total of 20 milliliters total. So the question is going to be, would 10 blue and 30 yellow be the same shade. So to do that, we're doubling it up here, so let's put in 2 groups of 5 blue, so 1, 2, that's 10. And now we're going to fill up with 30 yellow. That should put us at the 40 mark right there. So we're going to go 5, 10, 15, 20, 25, 30. And it does tell us here that it's a match, just in case your colors aren't coming through on the screen there. So yes, indeed, it does work out that it is the same shade. So the next question that it asks us to do is, it says, is the ratio in your mixture equivalent to the ratio in your teacher's mixture? Explain your reasoning. So basically, is 5:15 equivalent to doubling up and having 10:30? So is that equivalent or is it not? Now for our case, we would say that yes, it is equivalent, right? Yes, it's equivalent. And the reason is because when I'm doubling the amount of the blue, I'm also doubling the amount of the yellow. So what I'm doing to one ingredient, I do to the other. And when I do the same thing to both things by doubling both parts, I end up with an equivalent recipe or ratio there. Okay? Let's look at number 2. Number 2 says, well, let's go ahead and let's triple the recipe. Now again, to start with, we had 5 and we had 15. Now we're going to triple that up. Okay, so instead of 5, we're going to have times 3, we'll have 15 blue. And on the yellow side, 5 times 3 is 45. So if I draw this out, I'm going to have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. There's my blue. And then the 15 Y's, which is 45 altogether. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Something like that. All right? Single recipe, double recipe, triple recipe. Okay, so our new cup, if we had a cup of this, would be labeled as 15 parts blue for 45 parts yellow. All right? Now when we reset this here, we have to predict whether it would be the same shade of green or not. Now based upon what we've seen, if we multiply both parts the right way, then it should be the same green. Let's take a look at our GeoGebra thing here. We started off with 5 and 1, 2, 3 and 15. That was our initial. Right? So that's how we started this off. Now we're going to go to 15 blue, 5, 10, 15, and 45 yellow. 5, 10, 15, 20, 25, 30, 35, 40, 45. And at that point, it does tell us it's a match and we are set. Yes, it's a lot of fun to do it kind of in real life and get some eyedroppers out and food coloring, things like that, but it's what I have here at the house. It's just the iPad. So, is my ratio in new mixture equivalent to the ratio of the teacher's mixture? Explain your reasoning. Okay, and we would say yes, it is. Now your job now is to explain why it is. Why is it equivalent to what we had before? All right. Number 3 says to invent your own recipe for a bluer shade of green water. Okay, so right now our green water is in a ratio of 5 to 15, right? So if I want it to be bluer, then what I need to do is increase the blue more than I increase the yellow. So let's say I decided to multiply the blue by 3 and multiply the yellow by 2 for a ratio of 15 to 30. Okay? What would I end up having here? Well, I would definitely have green still because I'm combining blue and yellow, but the ratio is going to be changed so that I have a bluer tint to that. Let's see what happens if I do that. So on the left-hand side is my original. There's my 15, right? My 5 and 15. So let's go ahead and do the blue. Let's make the blue times 3, which is 15. 1, 2, 3. And then we'll make our yellow, double it, make it 30. Whoops, that was the wrong way. Make it 30. So 5, 10, 15, 20, 25, 30. And it's hard to see here in this picture. This, though, is a little bit greener than that one, which makes it a little bit bluer, technically. If I added some more blue to it, the more I add, the darker it becomes. So I get more blue, and it's going to be a darker shade of green. It's not really bluer, it's just more of a blue color. Okay? So less yellow and more blue makes it blue. That's the idea. So whatever number you put is great. Just make sure that as you're doing it, it will not be equivalent at that point. Okay? So B says label the final empty cup of what you did. So to make it work, label the final empty cup in the ratio of blue, water, yellow in this recipe. So for me, to make it bluer, I made mine 15 and 30. And we tested it. Does it yield a bluer one? We tried that out on, the little GeoGebra, and yes, it does. It's still pretty green though, okay? And is it equivalent? We would definitely say no, it's not, because we did something to the 5 that we did not do to the 15, so it doesn't work out that way. Okay, let's look at one more of these. Perfect purple water. The recipe for perfect purple water says that mix 8 blue and 3 red, and you get perfect purple. Jada mixes 24 milliliters of blue and 9 red. So 24 and 9. Andre mixes 16 blue and 9 red. Which person will get a color mixture that is the same shade as the perfect purple? Alright, so here's what we have. We know that we have 8 and 3 is the perfect mixture. Okay, so here's Jada, and here is Andre. We know we're aiming for 8 and 3. Jada has 24 blue and 9 red. Andre has 16 blue and 9 red. Okay, so to get from 3 to 9, that's going to be a times 3, correct? On both of these, that would be a times 3. So in order to have the same shade and to do the ratio in an equivalent way, we would have to also multiply the blue by 3. Well, which one of these is 8 times 3? Is 8 times 3 24, or is 8 times 3 16? 8 times 3, I would say, is 24. So Jada actually is going to have the same shade as the perfect purple. Why? Because she has written and done an equivalent ratio. 8:3 is equivalent to 24 to 9, because they're both sides are both colors are multiplied by 3 to get that one there. Andre, he doubled it. This is times 2, and that's 3. So this one would be actually a little redder shade of purple than the other one would be. So Andre's is not going to work there. Find another combination of blue and red water that will also result in the shade perfect purple. Okay, so no problem. So to do that there, we take our original ratio and we tripled it last time. All we have to do here is pick another way of doing something to both sides. Let's do it times 2. If we do it times 2, 8 times 2 is 16, and 3 times 2 is 6, and now we have a double batch to make the perfect shade of purple, just like that. All right? So, in summary today, looking at this one, when mixing colors, doubling or tripling the amount of each color will create the same shade of the mixed color. In fact, you can always multiply the amount of each color by the same number to create a different amount of the same color. So, what does that mean? Multiply the amount of each color by the same number to create the same mixed color. So that was our example there. So whatever I did here, we saw that if my batch is here, and that's my batch number 1, and I'm a 4 to 2, if I do it again, the same exact thing, then I end up with 2 batches. If I do the same exact thing a third time, it's 3 batches. So again, this is like times 2, and this is times 3 of the original. So those ratios then become equivalent because they describe the same color mixture. Alright, that's it for today's lesson. Alright, you can pause that and start to work on your homework, and we'll come back and check that together. Homework time. Here's a diagram showing a mixture of red paint and green paint needed for one batch of a particular shade of brown. Alright, so 3 reds and 2 green make a lovely brown color. Add to the diagram so it shows 3 batches of the same shade of brown. Okay, so to do that here, we would say, well, we're going to have 1, 2, 3 there, 1, 2, 3 there, and 1, 2, 1, 2. These are our reds up top, and these are our greens down below. So in doing that, I have 1 batch, 2 batch, and 3 batch in the diagram to make a lot more brown than what originally I was going to make. Number 2. Diego makes green paint by mixing 10 tablespoons of yellow, 10 yellow, and 2 tablespoons of blue, 2 blue. Which of these mixtures produces the same shade of green paint as Diego's? So our yellow to blue ratio is 10 to 2. That's what we're working on there. Okay? Now, for every 5 tablespoons of blue, mix in 1 tablespoon of yellow. So that would be like taking our ratio here and saying, okay, well, let's see. I have 2. Let's make this a 5 and make that a 1. Is that possible? Well, to go from 10 to 1, we've been doing multiplication. I could divide by 10. That would work as well. But what about 2 divided by 10? Is 2 divided by 10 equal to 5? No, it is not. It equals 1/5. So that one would not work. So we're going to say no to the first one. Mix tablespoons of blue paint, yellow paint in a ratio of 1 to 5. Now notice the order. Blue is 1. I'll put a 1 right here. And yellow is the second one, which is 5. So what's happening from 10 to 5 and 2 to 1? Well, 10 divided by 2 gets you to 5, and 2 divided by 2 gets you to 1. So you can actually decrease as well. So it's making less of the paint, but it still is the same color, same shade. And that would work. The next one, mix tablespoons of yellow paint and blue paint. So yellow to blue, and yellow it says is 15, and blue it says is 3. Alright, well, because I did 10 and 2, 10 to 15 is hard to find a little connection there, isn't it? So is 2 to 3. But because I've already decided that 10 and 5 and 1 work, look at this. I can also look at my new equivalent ratio. 5 to 15 is times 3, and 1 to 3 is times 3, so that would work. So sometimes it's helpful to make things a little bit smaller to kind of reduce this down to the basic equivalent ratio. It's like doing this. It's like saying I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to start with, and a blue and a blue. And rather than call this 2 and 10, we call it 1 and 5, 1 and 5, right? So we're just using we didn't do the picture start with, we just used numbers. So C would work there, no problem. Next, mix 11 tablespoons of yellow and 3 of blue. 11 and 3. Now that is much more complicated. Can I get an 11 and 3? 11 and a 3. The answer is going to be no, because I've already got a 15 and 3, so I can't do 11 and 3 as well. So we're going to say no to that one there. Number 3. To make 1 batch of sky blue paint, Claire mixes 2 blue with 1 white. So blue, white, 2, 1. Explain how Claire can make 2 batches of sky blue paint. So to make 2 batches, what you want to do, again, write in your own words, she's want to double each, so she would have 4 blue and 2 white. You'll want to write that out in some words so your teacher understands what you want to do. Explain how to make a mixture that is a darker shade of blue. Well, to make it darker, add more blue than white. For an example, okay, we could do triple the blue, 3 times blue, and 2 times white. What would that come up with? You'd have 6 and 2 in our ratio, and that would be a bluer shade than the original. If you want to make a lighter shade, then we want to add more white. So in that case, maybe you do 2 times the blue and maybe 5 times the white. So you end up with 4 blue and 5 white. That'd be a lot lighter, but it would work. Okay, number 4. A smoothie recipe calls for 3 cups of milk, 2 frozen bananas, and 1 chocolate syrup. Create a diagram to represent the quantities in this recipe. Okay, so we have milk, milk, milk. We have banana, banana, and we have chocolate syrup, just like that. That becomes my picture for what's happening there. The next question says, write 3 different sentences that use a ratio to describe the recipe. So let me just say some ideas. There's lots of ideas. You could say, for every 2 frozen bananas, there are 3 cups of milk. For every 1 tablespoon of chocolate syrup, there are 3 cups of milk. For every 3 cups of milk, there are 2 bananas. For every 2 bananas, there is 1 tablespoon of chocolate milk. Those are lots of different ideas. You can come up with your own and think of 3 sentences on your own that you want to say. All right, B, number 5. Write the missing number. Okay, we did this before. First of all, let's look at, I have here a span of 2 spaces. Let's see what the distance is. Because I'm going from here to here is 6. And so to find out what's in the middle, I divide by 2. And that tells me that I'm counting by 3s. So I have 0, 3, 6. 6 plus 3 is 9. 9 plus 3 is 12. And 15 plus 3 is 18. So it helps to find a distance you know. In this case here, divide by 2 to find out what that distance is going to be. All right, number 6. Here we have a parallelogram. I have a base on this side, which is the base of 1, 2, 3. And I have a height if I decide to, well, let's go this way. I have a height if I decide to go down right here and right there. That's my height. My height is 1, 2, 3, 4, 5, 6, 7. So my height equals 7 because I make that right angle. So the base times the height is going to be 21 square units. All right, that's a review question for us. And then finally, number 7. Complete this to make it true. So this becomes 11 over 1. 11 times 1 is 11. 1 times 4 is 4. We can leave it like that. So 7 over 1. 7 times 1 is 7. 1 times 4 is 4. Here, like 13 over 1 becomes 13 over 27. And here we end up with 13 over 99. And here, as long as y doesn't equal 0, we'd have x over y. Some good practice with some fractions there, and that's it for today. All right, that's it. Have a great day, and we'll see you next time.